Welcome to True Projects. In this video, you will be learning about prediction of cardiac disease using supervised machine learning algorithms. Introduction. Predicting and detecting cardiac disease has always been a difficult and time-consuming undertaking for doctors. To treat cardiac disorders, hospitals and other clinics are giving costly therapies and operations. As a result, anticipating cardiac disease in its early stages will be beneficial to people all around the world, allowing them to take required treatment before it becomes serious. Heart disease has become a major issue in recent years, with the primary causes being excessive alcohol use, tobacco use, and lack of physical activity. Machine learning models are utilized to forecast cardiac illness in this project. Objective of the project. The project aims to develop a predictive model using supervised machine learning algorithms to anticipate and detect cardiac disease. It trains various algorithms on the cardiac dataset from the Kaggle website, aiming to assess their accuracy in predicting cardiac disease. The evaluation metrics precision, recall, accuracy, and F1 score will be used to measure and compare the effectiveness of each algorithm, providing valuable insights for improving cardiac disease detection and treatment approaches. Requirements for the project are hardware requirements and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. Algorithms used in this project are support vector machine. It is used for its ability to handle nonlinear relationships and high-dimensional data, making it effective in predicting cardiac disease based on complex features. The second one is naive-Bayes algorithm. This is chosen for its simplicity and efficiency in text classification tasks, which can be applied to cardiac data for quick and accurate disease prediction. The next one is decision tree algorithm. It is selected for its interpretability and capability to create intuitive rules, aiding it understanding the factors influencing cardiac disease and providing valuable insights for healthcare practitioners. The fourth one is logistic regression. It is utilized for binary classification tasks such as predicting the presence or absence of cardiac disease due to its simplicity and ability to model linear relationships. The next one is random forest algorithm. Here it is employed to create an ensembling model and handle high-dimensional data, reduce overfitting, and improving the accuracy and robustness of the cardiac disease prediction. The next one is K-nearest neighbor algorithm. This is chosen for its simplicity and effectiveness in identifying similar data points, allowing them to make predictions based on neighboring instances in the dataset, which means it will be clustered into one group. Methodology. We have designed few modules for execution. In first module, which is upload cardiac dataset, in this module we will be uploading the dataset. In the second module, which is generate, train and test, in this module, the data will be split into train and test in the 8:2 ratio. The next one is run SVM algorithm. In this model, we will be performing the SVM algorithm on the 80% of the trained data, and then we will apply for the 20% of the test data, and then we predict the accuracy, precision, recall, and F-score. Now, similarly, we will be applying it on naive-Bayes algorithm, decision tree algorithm, logistic regression algorithm, random forest algorithm, KNN algorithm. And then in the last module, which is comparison graph, in this module we will be comparing the scores of all the algorithms. Execution. For execution of the project, first open the code folder. So this is the code folder, and this is the dataset file. And on this dataset, we will be building multiple algorithms. And this is the main file which contains the code in it, and this is the run.bat file. Instead of executing the program in command line interface, we have created the Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project, and this is created by using the library called Tkinter in the Python. First click on the button upload cardiac dataset. Select the CardioTrain dataset and click on open. Here the dataset is uploaded and it views some of the records of the data. Now click on the button generate train and test to split the data into train and test. Here, this is the correlation graph, which is heat map. Here the column names are represented, and these are the correlation values. The values which are close to 1 and These are represented as the positive correlation, and the values which are close to -1, they are referred as negatively correlated, and the values which are close to 0 and they don't have the correlation. So the values which are close to 1 and -1, they are the important attributes. Now we will be selecting those attributes for building the model. Here, initially we have the 10,000 records in the dataset. After splitting them into train and test, we have the 8,000 records in train and 2,000 records on test. Now click on the button Run SVM algorithm. Here, the SVM algorithm is first trained on the 80% of the dataset and then predicted on the 20% of the test dataset. These are the accuracy, precision, recall and F1 scores of the SVM algorithm. Now click on the button Run Naive Bayes algorithm. Here is the accuracy, precision, recall and F1 score of the Naive Bayes algorithm. Now click on the button Run Decision Tree algorithm. Here are the accuracy, precision, recall, F1 score of the decision tree algorithm. Now click on the button Run Logistic Regression algorithm. Here we have logistic regression accuracy, precision, recall, F1 score. Now click on the button Run Random Forest algorithm. Here we have the random forest accuracy, precision, recall, F1 score of random forest. Now click on the button Run KNN algorithm. We got the accuracy, precision, recall and F1 score of KNN algorithm. Now click on the button Comparison Graph to measure all the metrics. Here on the x-axis we have the algorithm names and on the y-axis we have accuracy scores. Here blue line represents the accuracy, orange line represents F1 score, green line represents precision, red line represents recall. Among all the algorithms, decision tree is performing well. So close this graph. Close this window. Conclusion. The project demonstrates that decision tree algorithm performs well in predicting and detecting cardiac disease among the supervised machine learning algorithms evaluated. Decision tree shows superior prediction accuracy. This finding suggests that decision tree can serve as an effective tool for early diagnosis of cardiac disorders, potentially reducing the time and cost associated with the treatments and improving the patient outcomes by utilizing the machine learning methods, particularly decision tree in predicting cardiac illness. Healthcare practitioners can enhance their ability to identify and treat cardiac diseases promptly, offering significant benefits to people worldwide in managing their health and concern.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.